Hi, welcome to my video. Before we can start to talk about the work energy theorem, there is a bit of background information that I should cover. The main types of energy include thermal, light, sound, potential, and kinetic energy. Kinetic energy is associated with an object's motion, and it can be calculated with the object's mass and velocity. Objects with a higher mass or velocity will have a greater kinetic energy. To find the work energy theorem, we must first take a few steps through different equations we've learned in previous units. We can start with the equation work equals force times displacement. We know from Newton's second law that that equation is equivalent to work equals mass times acceleration times displacement, because force equals mass times acceleration. And from the motion equation units, we can sub this in for the acceleration. Also from the motion equation units, we know that we can sub this in for delta x, and once you multiply it all out, you get this final equation. Since kinetic energy is equal to 1/2 mass times velocity squared, we can deduce that an object's total work is equal to its change in kinetic energy. Let's do an example. A 20-kilogram mass is pulled 10 meters by a rope with a tension force of 50 newtons. It starts with a velocity of 2 meters per second and ends with a velocity of 10 meters per second. Solve for the kinetic friction force. First off, we know the following equations: the work energy theorem, the equation for total work energy, and the equation for the change in kinetic energy. To start off, we can draw a free body diagram. The mass would have a normal force facing up, a weight force facing down, a tension force facing the direction of the rope and the direction in which it is being pulled, and a kinetic friction force resisting the movement. We can use the equation for the work energy theorem to solve. We can start with the right side of the equation and use the change in kinetic energy equation to solve for it. Once you calculate it, you will find that the change in kinetic energy is equal to 480 joules. We can now use the equation for total work energy to solve for the left side of the original equation. The net force in this situation would be tension minus kinetic friction, and you would multiply that by the displacement. We can now set the left and right side equal, and since we know that the tension is 50 newtons and the displacement is 10 meters, we can solve to find that the kinetic friction is equal to 2 newtons.